All right, so first off, so all of you hear this. I emailed this to you. This is your homework for Chapter 10. I emailed this to you a little earlier today. It's up on the screen as well. So if you look, there's 5 things to do. Number 1, complete programming exercise number 4, the package demo. You've got the hard copy. I want you to key it in. I want you to add the comments as well. All right? And I want you to add any other comments you might think are necessary. We're going to go over that in just a couple minutes. Same thing with number 6. I forgot to put in a program prologue, so I'd ask you to add that, but we're going to go over that in just a couple minutes. Number 7, which is very short, same kind of thing. Key that in. The one you're going to do on your own is number 9. All right? If you're able to do that, you really and truly should have no problems on the test. Okay? And then I want you to complete the debugging exercises. So there are 4 programs that you have to do. 3 of them are going to basically be you doing data entry. In other words, you've got the code already. You have to key the code in. All right? But I will tell you, I don't remember, I think these are like worth 10 points each. Okay? But the one that you have to do yourself, that's going to be worth probably half. And the debugging exercises are going to be worth 2.5. So those 3 programs that you are already given are going to be worth about, a point or a point and a half apiece. Okay? I'm not trying to be unfair there, but I should put more weight on the one you're doing yourselves. All right? So let's take a couple minutes, and notice you also have, those are due no later than a week from Monday. All right? All right, so let's take a look at these particular programs. I'm going to do them out of order. All right? Not because I can or whatever, but because number 7, I think it's the smallest handout you have of the 3 I gave you. But it says recovering demo up in the title. It's up on the top. I want to go over that one first because it's the shortest. All right. So when you look at this, it says what? We're supposed to create an application called recovering demo. It should declare 3 types of objects: a patient object, like a patient in a hospital, and a pollster object, which I think is pretty self-explanatory, and a football player object. All right? So the thing is, when you think about it, the word recover means different things to all 3 people, or all 3 kinds of people. A patient wants to recover from an illness if they're in a hospital. All right? And a pollster wants to recover furniture. And a football player might recover a fumble. All that makes sense? So 3 different kinds. We'll have to make 3 different classes and 3 objects, and an object of each of those kind of classes. All right? Each one of those should implement iRecoverable. What does that mean? That means you have to create an interface that's called iRecoverable. All right? And all that interface is going to have is an abstract method that's going to be called recover, and then you're going to have to write a recover for each class. All it is literally is a write line statement. So for the patient, it'll say something like, I'm recovering from surgery. For the upholsterer, it'll be something like, I'm going to recover my couch. For the football player, it'll be something like, I recovered my fumble. You understand? So it's pretty simple stuff. All right, so we're going to go through that one first. And again, the only reason I'm going through that one first is it's the shortest one. So you have this. Let me cut my size down on here a little bit. But I want to go through it and have us take just a couple minutes to go and take a look at literally what's in here. And as I'm doing this, as always, and I'm being serious here, if something doesn't make sense, all I can say is it's your responsibility to ask if something doesn't make sense. But if no one does, I have to take for granted that you all get it. All right? And the reason that that's important is all of this stuff, directly or indirectly, is going to be on your next hands-on test. So it's important that you understand the concepts. Okay? All right. So the first one, and please notice if you look on here with each one of these, I put all the classes, they're all in the same file. Because I just didn't want to have every, didn't want to print out this page or this, and then print out this, and then print out this. I put it all together. Does that make sense? But what we could have done is we could have taken this upholsterer class and put that in its own file, the football class and put that in its own file, the patient class and put that in its own file. But each one of them is only about 9 or 10 lines long each. That's why I put them all in the same file. All right, so when we look at this, what do we have? Well, right now, ideally at least, this makes sense to you. This line of code that you see in blue makes sense. This says we're creating a new object. The name of the object is the patient, and the type of the object is patient. Does all that make sense? So again, class name right here, patient. User identifier right there, the patient. Equal, new. So this is where you're doing the actual instantiation. So you're creating a new patient object based on that patient class that you see right there. Does that make sense? There's not much in this. You know, we don't have a patient name, we don't have a patient ID, we don't have a patient illness. We weren't told to do that. So we just create that, and then when you look up on the screen here, then it just says, you know, write patient message, and then what we're doing right there is we are calling a method. So we're giving it the name of the object, the patient, dot, and the name of the method. So that is a method invocation right there. That's what we're doing. And what should happen, I'm not sure if it does or not, but should, is if I say the patient here, dot, notice there's recover. See that? So it finds it in the IntelliSense. So when you're doing this kind of stuff, and if, well, it's not showing in the IntelliSense, probably you did something wrong. Just so you're aware of that. All right? All right, then we call the recover method. So what should happen there? That should write on the screen patient message, the \T are just a couple of tabs, and then it should write, I am recovering from my surgery. Does that make sense? Then we do the same thing, but we create an upholsterer object. And you'll notice that the upholsterer object looks almost just like the patient object, except the message that in here is different from the message that's here. So again, this line of code that you see right here in line 40, that is creating a brand new object. The name of the object is the upholsterer. The type of object is upholsterer. All right? Then we write upholsterer message in a couple tabs, and we write their recover message, which should say, I am recovering my favorite chair. Then finally, we do it one last time. We create a football player object called the football player. Again, there's class name, object name, instantiation. Then we're going to write on here football player message in a tab, and then the actual message for the football player, which says, I have recovered the fumble. So what should happen when we run this is it should say, on the screen, it should say patient message, 2 tabs, I am recovering from surgery. Then it should say upholsterer message, 2 tabs, I am recovering my favorite chair. Then it should say football player message with a tab, and I have recovered the fumble. Does that make sense? All right. And if I save this and run it, there's our output. It's exactly what we should have seen. I put the tabs in there just so stuff would line up. All right. I just wanted you to be able to see what was happening. But what that particular example shows is a couple things. First of all, look up on the screen if you would, please. This is an interface. That is not a class. It is an interface. All right? So all that has in there is void recover. All right? And basically, all of those are going to call this. All right? They're all going to end up calling it. Then we also have in here 1, 2, 3 different classes. Each class inherits from iRecoverable. iRecoverable, iRecoverable. So we have in this example, we've got an interface named iRecoverable. we have really 4 classes. If you look up on the screen here, we've got our class program that holds everything. And then we have our patient class, our upholsterer class, and our football player class. All right, so we instantiate the patient class, the upholsterer class, and the football player class. Then we tell it to go over to the interface and find that recover method. But that recover method, we've overwritten it every time. We want it to say what we want it to say for a football player, or for a patient, or for an upholsterer. All right? And if that makes sense, then you're on your way to understanding this. If it doesn't, I would take the time to go back in the book and read the section that's on interfaces, and if need be, at least bring up the code that the author has in the book on interfaces. All right? Any questions on this one? This is your chance to ask. All right, so that's the first one. Again, with this one, you will be responsible for keying that in. So again, looking at what I just showed you before, so that's this one. That's number 3. All right, complete programming exercise number 7, recovery demo, page 484. Add existing comments and additional comments as necessary. Next, please find the one that says package demo. That's the one we're going to go over now, package demo. And the first thing I want to do before we even go over it is I'm going to run it. But if you look up on the screen, please, there are 4 objects. There is one called light package, one called heavy package, one called inexpensive insured package, one called expensive insured package. We're going to go over what all those mean in just a second. But we're creating each one of those. So when I run this, that's what you get for output. So each one of those objects will have an ID, which is just a number that we come up with. It'll have a name because that's who basically, you can look at it as who dropped that package off at the place or whatever you want. We have a weight, and based on the weight, we have a delivery price. All right? And I just used me, Charles, Paul, and Jeremy, all people from here. All right? You know, it's funny, I used to do that where I'd put students in there, and sometimes I'd have students come up and say, please don't put my name in there. Or I have it the other way, how come you never put my name in there? You know, and I just don't want to do that. All right, that's why a lot of times I just use my family, but I didn't feel like that this morning, so that's why I use this. All right, so let's take a look at the code. Again, as always, I just copied the prologue from the book. So what it says is create an application. Create an application named package demo, which it is. There's somewhere in here. There's package demo, all right, that declares and demonstrates objects of the package class and its descendants. So when you look at this, all right, light package and heavy package are both of type package. So when I come down here, there's class package right there. All the stuff you see here in blue is of type package. All right, I'll take your question in a second. Then we have an insured package, all right, and what is it? That's of type package, okay? So we're gonna have 2 different kinds of those. And what it is basically it says if your package is worth $20 or less, the insurance is a certain amount. Over $20, it's a certain amount. And if you've ever sent anything through the mail, maybe you've gone through that already. I know that, you know, when my daughter was in college, we'd send her care packages and stuff. And if basically, especially if it was food or whatever, you know, do you want to insure this? Hell no. All right. But there was a time or two that when we sent her, for example, a couple times I had to send her. We had problems with Western Union, so I had to not send her money, but I had to send her a check or whatever. Then I would insure that. Does that make sense? All right. Question.
On the top, when you had the different objects that you were talking about.
Yes.
So you're able to put after the equal sign, you're able to put the new package. You're able to do that for multiple.
Yes. Yeah. That's just like it's the same way when we went through the example in class and we did the person class. Right. I could make a person for each one of you.
Okay.
And I did, but I used my family. But that's the same thing we're doing here.
That's just using like a hierarchy.
This isn't even, right here, these are just two package objects. But then what we do is we also create two insured package objects. An insured package is a type of package. All right? So just a regular package right here, just these. If you look in here, there's nothing in here about insurance. All right? But if it's an insured package, all right, then you care about limits and the like. All right?
Makes sense.
Okay, so the package class includes auto-implemented properties for ID number, name, and weight. So when you look in here, please look up on the screen. There's ID, there's name, and there's weight. Now, for weight, we couldn't use the auto-implemented because we had to figure out, because it's a certain cost, I think it's like a certain amount up to 32 ounces. Then after 32 ounces, it's by the ounce. Okay? And it said that in here, somewhere in here. All right, the class also contains a delivery price field that is set when the weight is set as $5 for the first 32 ounces and 12 cents for each ounce over 32. So in other words, the actual delivery price, if it's 32 ounces or less, is $5. Okay, but let's say it was 64 ounces. Then it would be $5 for the first 32 and then 12 for the next 32, 12 cents an ounce. So you'd have to add together the $5 plus 32 times 12, which is what, 384? So the whole thing would be 884. Does that make sense? All right. So let's just take a look at that. Let's forget about the insured for a while. Let's just look at this. All right. So when we look, we've got two, we are instantiating, and I'll put the comment here, instantiate two different package objects, because that's exactly what we're doing right there. All right. All right, so these are two different instantiations of package objects. So what that's going to do is it's going to go over and it's going to find package, and it's going to say, okay. All right. When we look in here, what are we doing? We've got some constants that we've set up. We've got some instance variables we set up. We got some setters and getters that we set up. All right. And we're going to figure out the price based on the weight. All right. So we do take the weight in, but then we say if that weight is less than or equal to 32 ounces, then the price is going to be $5. Otherwise, the price is going to be the $5 plus, and that probably should have all been in a paren now that I look at it, but it'll still work without it, plus the weight minus that weight. So if it was 64 ounces, that would cover the first 32. This would be 64 minus 32, which would be 32, times the price per ounce. All right? So when you look in here, when we look at these, this is what I want you to get out of this. And when we run this, what do we have? Well, we've got the first thing, 7777. That's the ID. There's the name. The weight is 32 ounces. We said that if it's 32 ounces or less, all right, that it should be $5, and that's what the delivery price is. Then we have another ID, all right, we have another name, we have a weight, 45 ounces. So that should be the 32 ounces, so that should be $5 plus the difference. So 45 minus 32 would be 13, so 13 times the price per ounce, all right? And that's how we get the 656. Now, when you're doing this kind of thing, I don't care if it's a test, an assignment, or whatever, this should make sense to you. When you look at this, if that's 32 ounces and it's $5, if for some reason you had 45 ounces here and it was less than $5, something is haywire with your logic. Does that make sense? That shouldn't happen. But weird things can happen. you put a wrong formula in or something. All right, it's possible that something like that could happen. And so where did I get that stuff from? Well, I got that stuff from right here. So there we set the ID for the first one, the name for the first one, and the weight for the first one. Again, since the weight is equal to 32, that's $5. With the second one, there's the ID, there's the name, there's the weight. Since that weight is more than 32, that's $5 for the first 32, and then 13, which is the extra ounces we have, times 12. So that should be $1.56 more. $5 plus $1.56 gives you $6.56. So that's how we got those. Any questions on the on the non-insured, just the package stuff? All right, because you're going to have to take a look at this. You know, I want it to make sense to you. All right, and I figured that there was something to be said to have you key in all this stuff, and ideally you're going to be making mistakes as you key it in. I did. All right, and you'll learn from those mistakes. So then by the time you do the last problem and you're doing it on your own, ideally at least, it will make sense to you. All right? Then we have these insured packages. Notice we've got an inexpensive insured package and an expensive insured package. What does that mean? Well, it says here, override the method for the delivery price to include insurance. $1 for packages valued up to $20 and $2.50 for packages valued $20 or more. So when I test that at a minimum, I should have one thing that's got a value of $20 or less and one that's more than $20. Does that make sense? All right. I only have 4 different objects in here, but if I was really testing and testing and testing the heck out of this, I would be testing more than 4 objects. I might have some default stuff, and we didn't set any default stuff. So there's a lot of different ways that you could add to this program. I just didn't want each one of these to be 300 lines long. All right. So we've got these 2 things. So what's different in here? We still have the ID, we still have the name, we still have the weight, just like we did here. ID, name, weight, ID, name, weight. But now we have to put the value of the package. The first one has got a value of $9.99. Since $9.99 is less than $20, the amount of insurance should be $1. All right. For the second one, since its value is $200, and since $200 is $20 or more, now the insurance should be $250. All right. And when we look at this, this is what I want you to see. So if you take a look up here, again, we said that when we did the package, notice that class package, there's nothing after it. All right. Again, don't put this in, but we could have said this. Not while the program's running. But we could have said this. We could have come in here and said, object. That is legal, remember, because everything inherits from object. But that's redundant to do that. You can do it if that makes it easier for you to understand, but there's no reason for doing it. All right? But when we get down to insured package, that is a type of package. So an insured package is a package. Remember, inheritance is that is a relationship. All right? So we've got our getters and setters, all the same stuff that we had in here. This is where it changes. All right? So notice in here, we've got a new thing called package value. And we'll go over that in a second. But we're not changing the ID. We're not changing the name. We're not changing the weight. Does that make sense? We're not changing any of those. Since we're not changing any of those, we just use what we passed in from the parent. All right? But we have to come in here and add our own package value. All right? So that's the only variable that we have in here. But that variable depends on, all right, so the low price is the least amount of insurance, the high price is the most amount of insurance, and the limit is where we cut it off. So again, less than or equal to 20, it's the low price. Greater than 20, it's the high price. We didn't have to use constants, but it sure as heck makes sense to use constants in here. Because over time, that's going to change. You know that over time, they're going to charge more for insurance. All right? And if it's the post office, they tend to change things quite a bit. Do you ever wonder why they made those stamps and put forever on those? Because it's just too hard to change the numbers and stuff. So they said, yeah, you're going to charge you more for it, but you can use them forever. All right? So when we get down to this, we just return, but this is what? Well, notice in here, because this is the most important part of this. Notice that there are times in here where we say base dot. Because what we want to do is we want to change the price. Where is the price defined? In the parent, correct? Since it's defined in the parent, and it's defined in the parent as being private, if we want to be able to, and the price is protected, and we want to change that, all right? Remember, since it's protected, we can change it in the parent or in any of the children, all right? But we want to make sure that when we're doing that, we're using, and we're saying here the base price, so the parent price. So if the weight is less than or equal to, okay, we already did all that stuff. So this we're changing, okay? And this is we have to add to it. So this is figuring out the weight calculation for an insured or an uninsured, but this, now we have to go and add the insurance onto it. So that's what we're doing there. All right, again, I put some comments in here. I didn't put a boatload of comments in here. All right, so it would be in your best interest as you're keying this in, if you, I think that's why you did that. Just put a comment in there. That will help you next week when you're doing your hands-on test. You go, oh, wow, he gave us a problem that was similar to that. Then you can have those hard copies with you, or you can bring that up, on your screen or whatever. All right, does that make sense? All right, then let's look at, so on the homework, so that is number 9, the salesperson demo. Again, please add a program prologue because I forgot to. So that's numbers 3 and 4. No, I'm sorry, that's numbers 1 and 3. So let's look at number 2, which was the shapes demo. That's the other handout that I gave you. All right. This is a little trickier, but it's not bad if you take a look at it. What we do is we create a generic type of class. We create a generic type of class that's called geometric figure. And we say that all geometric figures, regardless of what kind they are, all of them have a height, all of them have a width, and all of them have an area. And I don't know if you remember this back from your days in high school or whatever, but the point is, you figure out the area for a square is different than the area for a circle, which is different than the area for a rectangle, for example. They all have different formulas, all right? And the reason that I assigned this one was in almost any class where you work and you start working with inheritance and the like, you'll eventually do something with geometric figures. It just happens. All right. And then notice if you as I keep going down here, if you please look, that this class that we're creating, this class, see that word? Somebody tell me again, what does that word mean? What does abstract mean? It's on your test. Means you cannot instantiate it. You cannot do new with a geometric figure. All right, so in our hierarchy, if you looked at it, if we were making a hierarchy, we'd have up on the top here, geometric figure. And underneath it, we'd have rectangle, and we'd have triangle. And I don't know how much you remember from your math days, but a square is a special kind of rectangle. So we have a 3-level inheritance hierarchy. Level 0, level 1, level 2. Level 0, this right here, this is abstract, which again means that we cannot create an instance of a geometric figure because it's too general in nature. It's like what we talked about yesterday when we had pet. And underneath pet, we had dog and cat and pig type of an idea. Pet is too generic, so you wouldn't make a pet object, just like you wouldn't make a geometric figure object. So we make it abstract. And we make all of these in here protected, which means that rectangle and or triangle and or square can change the height, or they can change the width, or they can change the area. Does that all make sense? All right. So when you look at this, what does it say? Create an application named Shapes Demo. Well, there it is, Shapes Demo. All right. That creates several objects that descend from, when it says descend from, it means children of. All right? So, what you're going to find is rectangle is a geometric figure, triangle is a geometric figure, and square is a rectangle. But since square is a rectangle and rectangle is a geometric figure, by default, square is also a geometric figure. That's stuff that has to make sense to you. All right? So each geometric figure, as you already saw, has a height, it has a width, and it has an area. Provide get and sets for every field except the area. The area is computed and is read-only. Remember, if you look up on the screen here, what they say here with the area is read-only, it's kind of like this. So imagine that, and this isn't the formula, but imagine that this was our height, 8. And imagine this was our width, 7. And to get the area, you multiplied the two of them together. So the area would be 56. That's the read-only one, because when you're given a height, you're given a width, you're going to do a formula and you can't change the area because it's all based on the height and the width. That's exactly what the author is saying right here. All right. So I just showed you the abstract method called compute area right here. I even put a comment there. Declare abstract method. Since it's abstract, remember, what abstract means is you must put it in any class that inherits from this class. So I must have a compute area method in rectangle and in triangle and in square. I must. All right, that's just the way that it's set up. In addition, I'm going to have 3 additional classes. A rectangle class, whose area is determined by multiplying width by height. So what does that mean? Well, notice, there's class rectangle. It inherits from geometric figures. So again, rectangle is a geometric figure. All right? And what this says in English is, for the height and the width, they're going to get those from the parent. All we have to do is override the compute area, which says area is width times height. That's it. Okay? So that's the first type. The second type is square. Square is a rectangle. So whereas when you saw this right here, when you saw rectangle inherits from geometric figure, square inherits from rectangle. Again, the width and the height, ooh, that looks bad. Oh, that's right. This is with a square. They're all the same size. See what I'm saying? So even though we've got a width and height, they have to all be the same because that's what makes it square. So that's why we passed width and width. It really wouldn't matter. We could have passed height and height. We could have passed width and height because they're the same anyway. All right. But again, when we come down to this, we're overriding it. All right, and we're going to end up calling compute area, which is going to be down here someplace. All right? But the formula for this is different. Provide a constructor that accepts both the height and width, forcing them to be equal, and provide a second instructor with just one dimension and use it for both the height and the width. And then call the rectangles compute area method. So we've got 2 different constructors. All right? For square, the one here and the one here. All right? But then we end up calling compute area, and it says, well, where's compute area? There is no compute area in here. It's going to call the one from the parent automatically. All right? And since we don't have our own in here, we don't have to say base dot because it'll automatically grab the parents. And then finally, we've got a triangle, which again will inherit from geometric figure and whose area is determined by multiplying the width by half the height. So when we get down to triangle, we have to override the compute area method because it's done differently. So, as it says in main, after each object is created, pass it to a method which basically prints all the stuff out, then change some dimensions and pass it again. So when you look, we create a rectangle and we display it. We create a square and we display it. Then we change the square's height and display it again. Then we create another square and display it. Change that square's height and display it. Then we've got a triangle and we display it. And we change the triangle's height and we display it. It's not very pretty output, but there's the original one. Remember, height times width, so that's when we get the 12. Then we come in here and we change the area. I'm sorry, we change the, what is it? The width from 4 to 3. So now instead of 3 times 4, it's 3 times 3, which gives us 9. Then we create another square. 20 times 20 is 400. Then we change the height or width or whatever, or both. It doesn't matter. Then we've got a triangle. And that's 1/2 width times height, which is 6. Then we change the height of the triangle and do it again. So 1/2 of 20 times 4 would be 40. And that's it. Now, is that easy? No. Did I throw a hell of a lot at you in an hour? Yes. But you now have 3 hours to start on this today, all period tomorrow, and all period Monday to work on this. All right? Again, on Tuesday, I'll give you, like I said, that pretest, and I'll give you something that I'm hoping that you'll at least be able to get a good start on in a couple hours. Then in the last 2 hours, we'll go over it as a class. Then Wednesday will be the actual hands-on test. And Thursday and Friday, again, of next week, we'll go into the next chapter, which is chapter 11. All right? Sometime in there, I guess, we have to do the written test. We didn't do the written for chapter 10 yet. Is that correct? This was the written for 9? All right? And I'll leave that up to you. You can do the written, we can either do it, probably Monday would make the most sense, even though that's a lab day. So the first half an hour would be for the written test. All right, so when you come in here on Monday, I'll have the board filled again with basically the test on it. We can go through that, you'll take the test, and then the rest of the period will be lab, okay? All that makes sense? Any questions on anything I just went over with you? Again, sorry, that was a lot to throw at you in a short amount of time. All right? All right, then the rest of the period is yours. Thank you. Well, tabs, the thing is, spaces sometimes on different types of machines, all right, well, they won't always line up. Tabs should line up.